now that we've successfully read the pinout data, let's take a look at what PartBuilder got. So we did the pin extract step. Everything is green. We go to the pin explorer now. And what we can see is PartBuilder has segmented the pins into certain groups. So it's very smart about FPGAs. And it knows, okay, it knows what the pattern is for a generic I/O bank. So it assigned all 2,200 pins to generic I/O banks. It knows what the patterns are for Xever banks. So we can see MGT ref clock, MGT RX. Okay. It tells us what bank they're in. So this is bank 220, 221, 222. If we go back to the generic I/O banks, we can also see, we slide over, we can see the banks. So PartBuilder reads these pins and it understands the structure of the data that it got, and it sorts them into banks by bank. Okay. It knows the dedicated pins, so its algorithm knows that there's many pins that are designated for configuration and whatsoever. So it assigns them into a dedicated group. So these are pin groups that, because it's an FPGA and because this is Xilinx part, PartBuilder knew how to extract these pins. It took the MGT power and segmented it into 4 different groups. So it uses the names of this power. So the FPGA for a Xilinx Vertex Plus, it has right south power, right lower center, right upper center power, and then right north power. So PartBuilder broke these up into groups, and what we can do is organize what the symbols are going to look like based on these groups. So it gives, with these groups, we can segment the part into multiple symbols based on what group they're in. Okay, and in the FPGA power pins, there's 1,243 of those. VCC int, ground, VCC IOs, and all that. The next step in this process is to tell PartBuilder how we want to organize these groups into symbols.